Good morning, everybody. I hope you all had a good day yesterday, and you're ready for another good day of conference in Sub0. I'm moderating the XCM panel today with this lovely gents next to me. I'm Ben from Parity, working in the ecosystem development team. And I would start out with a short introduction of you guys, who you are and what you're working on.
Hey guys. Hello everybody, good morning. My name is Gorka. I'm a core developer that works in the Moonbeam protocol. Basically in Moonbeam we try to do, let's say, Ethereum compatible blockchain, which means basically not only being EVM compatible, but also, so basically the fact that you can port your smart contracts to Moonbeam and expect them to work as if they were deployed in Ethereum. So things like Etherscan and so on, those are the things that we try to make available for our developers.
Cool.
Yep. Hey everyone, how's it going? Feeling swanky? My name is Hoon. I am the CTO of Astar Network, and we are a smart contract platform just like Moonbeam, but we also support WebAssembly smart contracts, so you can build your smart contracts on Rust, assembly script, or any other languages that compels down into assembly script. And we call ourselves the Innovation Hub because we have our unique staking method called dapps staking, where smart contracts can earn passive income based on the support that they receive from the community via staking on their contracts.
Hey everyone, I'm Jonathan. I'm the CTO of Talisman, and we are building a browser extension wallet and a web dashboard for the ecosystem with a heavy focus on user experience and making the whole ecosystem safer and easier to use. So you can download the wallet extension or find the web app where you can participate in crowd loans and staking and view your portfolio across all of the parachains and the Solo chains in the Substrate ecosystem.
Sweet, thank you very much. I would start with one clarification because it has usually a lot of confusion in the ecosystem, and just make sure that we are all on the same page. So we have XCM and XCMP. XCMP is this thing that's like how Gav explained it, it's the telephone. So you have a channel where you can send messages, and XCM is the message, like the language that you're speaking. And we're talking today mainly about XCM, or most of the time only about XCM. I would start with the first question. From your project's point of view, how would you explain XCM and what it's enabling for you? And maybe we start from the other end. Jonathan, you want to go first?
Yeah, XCM, it's a language, like you said, but it's also a primitive. This kind of dictates a lot of the actions that users can take in the ecosystem. So from a wallet's perspective, we kind of have to forecast how this is going to be leveraged by the parachains and by the Polkadot core team to facilitate actions for the user. And then we have to kind of read into that and kind of articulate these actions to the user when they're kind of signing transactions and performing these extrinsics in the ecosystem and facilitate that in the best way possible. So a lot of our work is kind of downstream from what XCM is and what XCMP is, and kind of reading into the use cases and making sure that users are understanding them in the correct way so they can use that technology safely and really kind of understand the consequences of the actions that they're making.
Yep. Yeah. So for us, XCM is really what enables innovation to go beyond the single blockchain, and it allows cross-chain functionalities. Because, as Ben mentioned, and I think yesterday, one of the sessions also mentioned XCM and XCMP. XCM is, for me, I call it like XCM is like the JSON or HTML, while XCMP is the protocol, HTTP or WebSocket that actually sends the messages. And the way how we use XCM is we want smart contracts to be able to compose instructions to call functions in other parachains or other blockchains, really, because XCM is not limited to Polkadot, if you really think about it. XCM itself is a standard for invoking functions, messages, or defining locations in any account or any blockchain, really. So through XCM, we want smart contracts to be able to communicate with other blockchains, access their liquidity or even access their functions, especially for parachains where they have special palettes. being able to mix and match different features, different assets in other parachains to create a whole new industry. That's how we see the opportunities of XCM within Astar network.
Yeah, our vision is pretty similar to what Hoon just said. So basically, we like to call it connected contracts, right? So this concept of connected contracts is basically the concept of one smart contract platform being able to interact with another smart contract platform, right? But not only just that, right? So XCM allows us to actually bring functionalities that per se might not exist in moment, but right, but like since we have parachains which are supposed to be specialized in like specific topics, right, that they're good at, right? So XCM allows the smart contracts in moment to actually reach those functionalities, even though they are not offered per se in the parachain, right? So yeah.
Very cool, interesting. Hoon, you mentioned this concept, and I think it is actually on the topic of the panel. Like, we have cross-chain, right? And can you elaborate a little bit on the concept of cross-chain versus cross-consensus, where we were talking about like different consensus systems?
Yeah, so cross-consensus is, that's part of XCM. It stands for cross-consensus message, right? Because with different consensus algorithms, there's different block finality. There are different things you have to consider in order to actually establish a connection with other blockchains. But with XCM, it's just as standard for defining what a distributed ledger, the properties of distributed ledger. So it can function regardless of the consensus of the underlying blockchain. Every blockchain, we can assume that it has a account or multi-location. Every blockchain, we can assume that it has multi-assets or some type of assets. We can also assume that blockchains has this concept of transactions. So this is where really XCM, you can see that that's a foundation of how XCM sort of works in terms of a standard for blockchains. And cross-chain is when one chain invokes a call from another chain to create a totally unique use case. And the reason why you would want to do this is if you try to create all use cases in a single blockchain, we're going to see a limit here because blockchains are not infinitely scalable. There is a clear limit, no matter what kind of consensus algorithm you use, no matter how fast the block time is, no matter how light the block is, there's going to be there's bound to be a limit when you want to satisfy all use cases. So that's why it's better to delegate certain features or certain assets to another blockchain, and being able to leverage that feature, that's the dream of cross-chain.
I'm super interested how this works from a wallet point. If we say like, now we have cross-chain, like multiple parachain in the wallet, and you interact with them, and I know that you guys support Polkadot accounts as well as EVM accounts so far. And we will see the bridge in the future to Ethereum, for example. How do you imagine that this future could look like from a wallet standpoint if you add another consensus system to the whole game?
Well, to answer the first part of the question, one of the main kind of consequences of XCM for the wallet is suddenly the user has a pattern where one key pair is active on multiple chains at a time. So we've had to kind of reimagine the abstractions inside of the wallet to represent that information correctly. So when they're using multiple chains, maybe with the same consensus mechanism, that works pretty well because you can have the same kind of key pair curve or something, and the private key can sign all the transactions and all the chains, and you can make that abstraction in a reasonably tidy way. But as soon as you start kind of mixing consensus mechanisms, suddenly you might have to have like one key pair that's for, I don't know, the Bitcoin consensus mechanism, but then that can send some XCM message to something else where there's a different key pair, and both of those are inside the wallet. And luckily it's not something we've had to tackle so far because we're just dealing with the Polkadot consensus mechanisms and a relatively standard set of key pairs. But I can imagine that we have to find some abstraction in the wallet which kind of buckets or bundles users' accounts so they can say, look, I've sent some XCM message between the same account, maybe it's like the same seed phrase, but between different key pairs, and kind of straddling the line between articulating that to the user correctly so that they can custody those secrets in a safe way, but also abstracting that away from the user so they don't need to onboard into these more complex topics like different consensus mechanisms and elliptic curves. So it creates a tricky paradigm for us where we just want to make a really usable product, but at the same time a really safe product.
That sounds very complex, to be honest. Based on the different account schemes from EVM and from substrate nodes, how does this impact for Moonbeam in the context of XCM? I mean, you send something from a parachain, from a substrate node, from a substrate-based parachain to Moonbeam, and then you expose it to the EVM world, and you suddenly have a new key pair in that sense. How do you how does this connect with XCM, and what do you think is the solution for that?
Yeah, luckily the XCM language is rich enough, so like several type of accounts, well, actually locations can be represented, and one of them is actually the 20-byte account. Like there's more, of course, 32-byte accounts, assets, whatnot, right? So I think the fact that we have a rich component there that can allow us to represent 20-byte accounts, that's actually amazing. But it is true that there's some challenges with respect to assets, right? Because one would expect that when you, for instance, transfer an asset from another chain to Moonbeam, that asset is visible for the EVM world as well, right? So that's something we actually thought about a lot in Moonbeam. The solution we actually made up is basically to give or to convert these assets or represent these assets as regular ERC20s with the same interface and so on, so that EVM projects can still access these functionalities that have been brought through XCM, right? So in this sense, yeah, we create an account per se for each of the assets we bring, and that's already visible by default for the EVM projects.
Actually, I could also add on to that because as you know, we're also a smart contract platform, and we support both native account schemes and EVM account schemes by default. We try not to do anything funky with those account schemes, like not try to hide one or try to add custom logic that allows control over the other accounts. So developers can, or users can use EVM account schemes, EVM smart contracts, and WASM smart contracts, and native accounts as they are. Now this imposes a lot of challenges, because that means if we're doing cross-chain message sending, we have to do twice the work that Moonbeam does. So that means less time for me to chill out. But we have this custom function that allows arbitrary code execution between any account schemes. This was a challenge with XCM that we had. Especially asset movement is more or less manageable, but arbitrary code execution, i.e. smart contract or cross-chain contract execution, becomes a challenge. So we created a feature called XVM, which is short for cross virtual machine. And what this does is essentially allows WebAssembly smart contracts to execute Solidity or EVM smart contracts and vice versa. And what this enables or implies is that any ERC20 smart contracts or PSP22 assets made by smart contracts in our blockchain could be transferable and controllable in any other chain as well, so instead of having to register them through an asset palette. Though this part, it's really hard to create a standard and easy-to-use SDK for general developers to access it, but we're working on that. And I will be giving a workshop in 420 Blaze It here. So I want everyone to join it if you want to learn more about how this works.
What stands the abbreviation of XVM for?
Sorry?
What is the abbreviation?
XVM.
XVM?
Yeah, the application
is it cross virtual machine?
Yes, cross virtual machine. So seamless interaction between two virtual machines. I mean, two, because right now we're supporting WASM and EVM, but it could be scalable to really any number of virtual machines and account schemes as long as the layer 1 blockchain can handle it. And this, it's really nothing too complicated if you look into the hood. We just have an encoding, we have a standard encoding of how we serialize smart contract interactions, we just pass that through the palette, and it makes a call within the other environment. And through this, you can control EVM assets through your native account and control native assets through your EVM account.
You guys are giving us lots of gray hairs at Talisman, where there might be like a user pattern where a user has their substrate key pair and they can XCM assets from the Polkadot relay chain to A star. And that's great because you're on the substrate side of A star. But then they can perform some action in the XVM to manipulate some assets on the EVM side of A star. And that's in some kind of mapped account where the user can access specific functionality that you guys have defined, but not necessarily sign arbitrary transactions with that Ethereum account because they don't have the private key. So we have to be really, really careful in how we articulate that address to the user and say, look, you can have assets here, you can have some assets in this account, but at the point where you think you can just inject this into an arbitrary application and sign the transaction like you would with kind of a regular key pair, you might not be able to do that. It's going to be an interesting kind of 12 months as we see more of these use cases kind of become established, and we can see how the user can navigate their way around these different addresses which they now have access to.
That was a good segue into the next question. What use cases do we see, or do you guys see right now on the different parachains as well, from the wallet experience in the ecosystem? Gorka, you may.
I'll start, yeah. So nowadays we usually just say, asset teleporting and asset reserve transfers, right? So the difference between these two is just teleporting implies burning the token in the origin chain and maintaining the destination chain, whereas reserve transfers, the tokens are locked in a specific account that the destination chain controls. Okay. So these are the two main use cases that we're seeing nowadays, although it is true that in Moonbeam we've been leveraging a use case since I think it was 1 year ago, in which we do liquid staking in the relay through XCM. So basically, actually it's Lido that, the project called Lido that basically stakes DOT and issues ST dot in exchange, right? So, and this is all done through XCM, so they stake from Moonbeam through XCM in the relay chain. But beyond that, obviously these use cases are starting to be we need more than this, right? So as we get more knowledge, as the XCM instruction set gets richer, et cetera, we need more use cases, right? So we're actually starting to test use cases in which we do remote EVM calls or remote smart contract calls. This is only so far enabled in our testnets, but we're already seeing that this enables a whole set of new use cases in which, as Hun said before, we leverage functionalities in other chains, right? Like, I don't know, we can call Manta for privacy, you can call Oak for scheduling, etc., right? So all these kind of use cases are going to be powered by the fact that we can do remote transactions in a different chain.
Could you elaborate a little bit on the remote smart contract call? What is it actually, or what can you do, or how can you envision this? That
basically means you interact with a smart contract that exists in Moonbeam or in any other smart contract parachain, right? And the transaction is originated not in Moonbeam per se, but in a different chain, right? Like, for instance, you can do from Astar to Moonbeam a smart contract interaction, let's say a swap in Uniswap or whatever you figure out.
So I would have, say, a dApp smart contract thing on Moonbeam deployed, and I could interact on Astar directly from that smart contract set and trigger some transaction or something on the Astar side.
Right. That's exactly what it means. That's the whole concept of what we call connected smart contracts. Yeah.
Interesting, super cool. One question, or not question, but one word that comes along with XCM a lot is asynchronous. Maybe you want to elaborate a little bit why asynchronous is so important for XCM and what it actually means in case of in relation to use cases and implementations?
Yeah, so asynchronous at its core just means that you're handling certain processes out of sync. So let's say, for example, smart contracts. Smart contracts right now, the ones that we see like EVM or Ink are transactional. So whatever function comes in, it has to be processed within that single block, and then it finalizes in that block. But in smart contract, asynchronous functions means that the transaction could actually wait for a couple of blocks until a certain condition is met. And the reason why in XCM this is important is any cross-chain functionality is asynchronous by default. because we do not share the block time. Our blockchain does not share the block time of other blocks, other blockchains. And when there's the system clock is different, it's asynchronous. There's no guarantee if it's going to be successful or not. So you just throw it, hope it goes well. That's actually how it works in XCM v2 right now as well. Just throw it in. If it goes well, that's good. If it doesn't work, oh my God, what am I going to do now? And there's no way to really properly debug it too. It's really complex. But having asynchronous functions means that you can leverage those cross-chain functionalities natively within the language, at the language level. So imagine, let's say, one of the reasons why we are really betting on Ink and WASM smart contract is handling asynchronicity in EVM is near impossible. I don't want to say completely impossible because I know people can do magic with as long as it's Turing complete, they can create magic. So I do believe that's probably technically way to do it, but it's much easier to do it in WebAssemblies based virtual machines. Like Gear has the actor model. I believe CosmWasm also has actor model too. So handling asynchronicity is much easier. And what we can do here is, so let's say we have asynchronous functions in our smart contracts, or developers can create asynchronous functions, then we can send an async function that is essentially calling or sending a message to another blockchain, and it could wait for a response from that blockchain and handle whatever response comes in. And this also ties back into what XCM v3 enables, which they add this another instruction set called the expect instruction set. So right now, when you send an asset, it's just send and that's it. But with expect, you can have this message called expect asset. So you're expecting an asset to come in from another blockchain or another parachain, and you wait, and if it's not what you expect, then you branch out into a different outcome, and you can program all that behavior. I mean, XCM is just a message format, though, so the behavior itself is something you have to program as a parachain. But the message format is there, so meaning that we can now expect something to happen, and that has huge implications for asynchronicity in smart contracts, because now we can expect certain messages to come in. If it doesn't come in, then the contract side can handle things. So we're giving the power to the developers to leverage cross-chain functionalities instead of having the palettes develop everything by themselves.
That was a long answer, but a very detailed answer. Anything to add from Moonbeam, from Gorky, to the asynchronous point?
No, I fully agree with what Hun has said. I would even go farther than that, right? So right now it's not even like with tokens, right? That you don't know what's going to happen with those tokens that you transferred. Also with the remote transactions, right? If you started playing with remote execution, right, in other chains, the truth is right now there's not a clean way to know what happened to a transaction, like whether it errored and why it errored, right? So those are things that are going to be fixed by XMB3, and I think it will make the communication between chains much better, in the sense that we're going to have the ability to wait for a response on the transaction status, right? That's something that I think will make the whole flow of this asynchronous communication, right, much better, much usable by users, by developers.
Talking about XMB3, we have heard it's around. It will come out very soon, get deployed.
Very soon, trademarked. Yeah, we don't know when it's very soon.
Trademarks. Soonish. From your point, I guess you have all looked into what XCM v3 brings and what you would expect from it. So could you elaborate from your side on, start with Moonbeam, what do you guys really look forward that XCM v3 brings in, and what it will improve from the usability, from the technical implementation, and how you would see the difference compared from what is there right now and what we could expect, say, 6 months, 12 months, whenever it is available?
Sure. So I would divide the features that XMB3 brings into two categories, like those that improve upon what's right now, upon the instruction set that we have right now, right, and those that bring new, let's say, like functionalities to the instruction set, right? So, so the first ones, right? I think the more important, in the first category, right? We have all these instructions that we said that are going to be available about response handling, right? Like one very complex thing with XCM is that the fact that when you construct a remote call, for instance, you have to know the encoding of the remote parachain, the transaction encoding for the extrinsic encoding for the remote parachain, okay? So those are things that are going to be improved in XMP3 because there will be instructions that will allow us to expect some encoding, and if that encoding is not what we expect, we can take a different path in the execution, right? So those are things that will improve the usability over what we have right now. Now, there will be more use cases that will arise, mainly because XMP3 will bring NFT transfers, which actually Hector yesterday from Variety showed a very nice demo in which he transferred an NFT from between two parachains. So I think that's very good news, to be honest. And then I think the main one that will be brought by XMP3 is the fact that you will be able to talk between different ecosystems, right? So what this means right now, with XCMP2, you're only able to exchange messages from within the same ecosystem, like Kusama or Polkadot, right? But the fact that with XCMP3, you're going to be able to bridge messages from one ecosystem, say Kusama, to another ecosystem, like say Polkadot or any other, or Ethereum or any other consensus system.
Is that the part of universal location and then multiple consensus systems?
Yeah.
How will it impact, or what would you imagine it impacts from the wallet side, Jonathan?
I think just building off your answer there, the NFT transfers is a kind of a nice primitive, a nice tick to box, so that's available for application developers and users. But from the wallet's perspective, error handling is a really lovely addition. We can kind of bubble up the errors that exist with any XCM call that goes wrong and kind of present that to the user in a way in which they can understand exactly what's happened and whether or not they can action something to remedy it or wait or something like that. But I think the main benefit, or what I'm looking forward to the most, is where we can find different types of use cases with like the remote contract execution. So we can move away from a world of XCM where it's mainly just kind of teleports and reserve asset transfers, where the user has to kind of manually do the cognition of, all right, I need to get this asset on this chain, and at that point I can make the interaction that I was planning on making, and maybe towards a future where that's kind of bundled, or it's just a remote execution from the origin chain to make everything a little bit more seamless and interoperable across different chains. That's probably the thing I'm looking forward to most. But we need to do the work of articulating that to the user. Right? We're kind of moving away from an approval window in a wallet which says, look, you're going to be making an action on this chain, so your state of this account is going to change in some way, and towards a future where you're going to have to articulate that, look, you're going to submit an action, and the state of your accounts on multiple chains is going to be altered by approving this action, and is that something that you want to do, and are you aware of exactly the consequences, maybe some ramifications with fee payments as well. So I think that's where the most utility is going to be unlocked with V3.
Would that actually mean that the wallet suddenly creates some sort of intelligence because it gives the user a suggestion on what to do in abstracting this? Because you would just say, okay, I want to use a feature, but I don't really care kind of where it happens on chain. Is that the right way to think about it?
I don't know if I would call it intelligence. It's more so the wallet just cares less and less about the chains which the functionality is on, or at least it cares less and less about articulating that to the user, where the ecosystem is represented as kind of a collection of chains. There's functionality in all the parachains, and the user just knows that they're kind of making an action within that kind of collection. So I don't want to call that intelligence, but it's just a different abstraction, right, for the user to think about. They're no longer kind of having a network selector saying, all right, I'm going to now switch to do some actions on Moonbeam. You know, you're just in the Polkadot or Kusama ecosystem, and that's all they're aware of.
I think that's pretty amazing, though, because the thing is, right now everyone thinks about things in the blockchain layer, what blockchain they're deploying on, what blockchains are capable of, but ultimately, if we want Web3 to be something that's more massively adopted, then the user should not care about which network or which blockchain they're using. All they have to care is, what assets do I have access to? What can I do based on this interface or this product that I'm using right now? And I think what Talisman is doing the first step to enabling this, and that is achievable thanks to XCM, really.
That's a very good answer, because my last question would actually be, how do you guys see the future of cross-chain interaction in like 12 months? what do you think would be different? How you would envision that?
I guess I could start. For us, we want to create the developer platform where you can access any blockchain, any feature, mix and match different liquidities, assets, functions that is only available in other blockchains as part of your business logic. So what this means is developers should be able to use blockchains, program blockchains as if they're just using another API or just importing another interface. That's why Rust is so perfect for writing smart contracts, and is trying to abstract a substrate function in Solidity there's a lot of margin of error, let's just put it that way. And that's the future we want to create. We want developers not to think about which blockchain they should build on, but think about what they should build. And just purely focus on the functionality and the value that they provide to the end users, to their community. Create something that's actually usable and not something that's just about pumping up the price.
That sounds very good. How about from the Moonbeam side, Rogarka, how do you think?
Yeah, so we expect basically the remote interactions between chains to be more common, to be honest, right? So right now it seems that the technology is there, it can be done, right? But it seems that we're still doing taking baby steps, right, towards that. Mainly because this is a complex thing, right? This is a bleeding edge technology, things can go wrong, etc., etc. So we want to make sure we do it right, and we there's no problem with that. But it is true that I think we have to, the ecosystem as a whole, right, has to take a step forward on the standardization of how the XCM communications will be, right? So that's something that has to improve, and that has to, right now, each parachain, we configure our XCM palettes and runtimes, to match our needs, right? But we don't think that much on how the user will be able to actually interact between our chain and the others, right? So I think that having a standardized way to do that, I think that's one of the goals we should have for the next 12 months, definitely.
Nice. How does the cross-chain interaction future in 12 months looks like from a wallet perspective?
I think there are kind of two answers, or two parts to the answer. Firstly, from a user's perspective, I'd like to see a future where the user is less and less aware that they're using XCM. I mean, the action just kind of works. Maybe you're using Oak Network to do some scheduling to kind of auto-compound rewards or something like that. And that's kind of articulated as the use case. But beyond that, they just need to worry about understanding that action, and not necessarily understanding that you're going to send a message from this chain to that chain, and something's going to happen and it's going to get sent back. From the user's perspective, it's safe and it's usable and it's easy to understand. But from an engineering perspective, I'd like to see a little bit more, I don't know if standardization is the right word, but a little bit of consolidation on how these XCM messages are called. There's currently 3 or 4 different palettes that construct XCM. There's X tokens, X transfer, palette XCM. And I remember having a conversation a few months ago where someone just said, look, XCM is a language, it's a standard format. So we should kind of leverage that fact to make it a little bit easier for developers to interact with these actions, and not have to be compatible with all of these different palettes that are really kind of having the same outcome, and instead leveraging the fact that we have a defined format to create some nice tools for developers to access XCM, no matter what palette or kind of implementation a chain has chosen.
Very last question. What tools would you like to see to make it easier to use XCM? I know that Moonbeam is working on XCM SDK, something like that.
Yeah.
It's called.
Yeah. I mean, it's basically a step forward a little bit on. So basically, one thing we encountered, right, is that if you're a developer and you're trying to do token transfer, right, from one parachain to the other, there's a whole there's a bunch of things you need to know about the XCM before you construct the code that actually sends the tokens to another chain, right? So so Moonbeam SDK is basically a step forward to just abstracting a little bit what's behind and the instructions that you're sending, and basically having more like a proper language, let's say. I'm not going to call it language, but a proper interaction, where you say, hey, I want to transfer these assets to this chain, to this account. That's it, period. You don't need to know anything else. Nothing about weights, nothing about multi-locations. and nothing about that, right? So yeah, but still, there's a lot of things to be done. One of the things that Hoon mentioned before is that it's very hard to debug XCM right now, right? So I've encountered many times the situation in which chains talk to us and say, hey, this message failed, and we're like, yeah, we don't even know the message that you sent. How are we going to know why it failed, right? So in that sense, yeah. So basically, because everything you see in Polkadot.js, it's just an encoded byte block, right? So basically, one thing we need to construct, and I think my teammate Alberto is going to do a demonstration about that in the afternoon, is how we had to go through the process of constructing a tool that is able to at least show us the message, and from there, figure out what went wrong. Okay, so but fortunately, there's a lot of projects right now that, like, starting from Subscan, Polkaholic, etc., right, that are already providing visualization on what messages have been exchanged, and I think we need basically to have more of this, right? So to have better understanding of what messages are being exchanged, and yeah, so basically everything that faces the user and that helps the user understand what the hell happened, I think that's going to be a nice tool to add.
Are these tools so generic that you could use them from multiple parachain teams? So can you use the same on A-star as well?
Sorry, can you repeat the question again?
Are they, like, these tools usable for multiple parachains? Is this like kind of the same problem that you would be reusable on A-star?
Well, yeah, first, I totally agree with what Gorka said. Like, that is a huge problem, and what Moonbeam is doing is absolutely amazing. Like, without that, I feel like XCM development will just not move forward. So really, it's so amazing. And hopefully, yes, it's reusable. I say hopefully, because things you never know. Like, yeah, and there's also certain cases where you really have to tailor it towards your network because of different implementations and how we approach XCM. XCM itself is the same. It's not going to change, and probably debugging in terms of like how it's actually the message was sent and how like understanding all these stuff. That tooling more or less should be reusable. Yeah, but then again, like it also depends on to who is it going to be reusable. Mainly EVM developers, Rust developers, or for Palette developers. That could be a little bit of a challenge. But either way, like I think it's actually absolutely amazing. Yeah.
Perhaps the direction we should go is to have a common API that no matter how Astra implements, like, you know, their account conversion to dispatch remote calls, right, or Moonbeam, like how it converts accounts, right? So perhaps having a common API that, you know, wallets or you know, explorers and so on can access. I think that's probably the way.
Absolutely. Yeah. There you go, folks. Official. Moonbeam and Astra collaborating.
Well, very nice. It's cross-collaboration, is it? Yeah, that was like my last question. Anything to add from you guys before? I would open it for a couple of questions. We have like apparently 4 minutes left or 5. Anything to add from you guys?
Well, I guess for me, XCM opens up the future for so many developers, so many opportunities. So really happy to see what Moonbeam is doing, what Talisman is doing as well to contribute to this. So I encourage everyone who's new to Substrates, coming into the Polkadot ecosystem or already in the Polkadot ecosystem, to really, I encourage them to create the most craziest thing you can with XCM, because that's how innovation starts.
Yeah, I would add to that and say this is a great opportunity for all the builders to just have an opportunity to reason from first principles. I mean, this isn't a problem that any ecosystem has had to tackle before, or these kind of high fidelity cross-chain messages being sent. And it's an opportunity to kind of rethink the abstractions in your applications and rethink some of how you construct your app. And it's kind of exciting to have a challenge that no one's faced before. And reason from first principles. So that would be like a call to action, is to just clean slate any biases you've kind of taken from other ecosystems and be ready to tackle something new.
Yeah, for me, I would say that luckily, like nowadays, we're not in the same stage as we were 8 months ago, where we were just trying to, like, all together trying to discover how XCM work and what could we do with it. So I think it's a great time for developers to start using it, because there has been some kind of, you know, standardization in some way as to how to use it. So I think I would encourage developers to try to imagine situations in which they don't stay within their local consensus system or parachain, but they should imagine like how to reach functionalities that exist in other parachains, basically.
Nice. A couple of call to actions and a lot of opportunities to get involved. Are you ready for a couple of questions?
Depends on the question.
Well, we see later. Do we have questions? I would open it up in from the audience. I see one over there.
Yeah, I would like to ask, what's the reasoning for forking the base Substrate and Polkadot palettes into your own repositories? Because it kind of makes it harder for developers to integrate with other palettes. We have some duplicate issues. If this is just the beginning, and maybe later on you would just use the base GitHub repositories for Substrate, Polkadot, Cumulus, etc. Thank you.
I can answer to that one. I mean, specifically, I'm guessing you're asking why we fork the repositories, right? And what's the reason behind it, right? To be honest, with Moonbeam, the case in which we had to do those kind of things, or actually we did quite often, but because we want our release process to maybe tailor our needs more than what. So for instance, I'm going to put you an example, right? Let's say we PR Substrate. That PR is approved, but it might not get into next release, right? So the reason why we fork is because we can just incorporate the change, right, and have it released like at faster times, right? But yeah, in the future, if like every change we try to propose to the official repositories, we try not to have like commits basically that are not in the upstream repositories. So basically, in a future where we don't have, let's say, the need to incorporate changes that haven't been released yet in the upstream repositories, I think we can probably forget out forking and just use the upstream repositories.
One more question? Yeah.
Thank you. Regarding the debugging, interchain debugging challenges that you mentioned before, are there any efforts being made that you would like to make a particular shout out on, or examples of what you think are good examples of being done that are helpful to you and your interchain debugging efforts?
You answer? I mean, okay, that's fine. My area. So yeah, to be honest, right now the debugging process, it's basically a mix between you being able to see the message, right? That's the first challenge, right? You don't get, if you go to Polkadot JS apps, you don't get to see the message, you just see the bytes, right? So that's something very limiting, right? So basically, the debugging process right now, it's a mix of being able to see the message and then understanding what the configurations of the parachains are to know why the message didn't go through, okay, or what happened with the message, right? And to be honest, I think right now I'm not seeing that many efforts on trying to mix those two pieces, okay? Mainly because parachains have very different configurations. That's the main thing about this, right? Now, that being said, I think there's room for certain errors to be able to debug them correctly. For instance, let's say you issue a transaction and you didn't put enough weight to cover the transaction, right? That kind of errors, I think those can be incorporated into kind of an official debugging tool, let's say. But there's other more complicated errors you didn't buy enough fees, but that depends on how much the chain charges for XCM, right? So those are a little bit more complicated, and unless we have a way to retrieve this data from the chain somehow, right? Right now, if you want to know how much Moonbeam Astra charges for an XCM message, you need to go to the runtime code and check it, right? So as long as we don't have a common API that we can use for that, I think it's going to be difficult.
What about leveraging some of the test nets to kind of have a better debugging flow when you're in development? I know Rob gave a talk at Decoded where he kind of pitched Rococo as this parachains cross-chain playground where you can start to develop some of these cross-chain use cases there first. I'm not sure if we can have that or a similar setup with some test nets as a debugging workflow for you guys to kind of iron out any differences in fees or something like that before it goes into the main chain.
Yeah, I mean, I do agree. There should definitely be a thorough testing workflow established, that's for sure. But the problem with Rococo is the availability is one thing. Like it's not always available when it's when you really need it. Let's just put it that way. And another problem with XCM or integration, like sending messages between different parachain is there's two major components. To simplify, there are two like major categories of issues, I would say. One is when you're actually composing and sending the message. The other one is how the message is interpreted from the other chain, and that's what Gorka sort of touched on as well. And the problem here is to fully debug and to fully understand how the message is actually going to be executed on the other chain, you have to understand how it was implemented and interpreted in the other chain. That is very time consuming. Having a standard API will definitely help make it a little bit easier to see like where the cause might happen, but the fact that you still have to dig deep into the other person's implementation it doesn't change. And I don't know, it could kind of makes definitely having a better testing workflow helps, but will that be a solution? I can't say at this stage. Like it's still not enough.
I mean, hopefully though, like tools like Sub0, right, might help regarding that, right? Like being able to replicate a message that happened between two runtimes, let's say, like Moonbeam runtime and Astra runtime, for instance. That I think that's going to help, right, as well. Like, if you're able to launch like a parachain and like debug a message or send a message in the range of minutes, right? I think that's going to help to understand like what the hell happened there, right? So
like using ZombieNet to really test it beforehand, if ZombieNet works well, that is.
I can guarantee the Rococo problem is solvable. We can do this and use it in the future. Well, with that said, I thank you so much for your time and sharing all your knowledge. And we'll wrap up the panel for today. And have a good day.
Thank you.
Thank you, guys.
Thanks, Ben. Thanks.